Hello everyone, in this video I would like to discuss the problem E of Codeforces round 857. In this problem we are given that the boy with a has n albums and each album will be having ki tracks. Now he would like to invite her friend Masha and she will listen the n albums. And now Vidya knows that if Masha listens to a track that was cooler than all the previous ones, then she will get 1 unit of impression. Okay, so now Vidya would like to arrange the album such that the impression for Masha is maximum. And one thing to notice here is that Vidya cannot rearrange the order of tracks. He can only rearrange the order of albums. So let us see how we can rearrange the albums. Let us try to observe something. Let us say we have two tracks. For first track, their coolness value for first album. Let us say we have two albums, 1 and 2. For first album, we have some track whose coolness values are this. Let us say this. For second album we have coolness values of tracks as this. Okay, and let us say 10, 3, 5. Okay, so we have this coolness value of track for the two albums. Now can you tell me in which order should I keep this album so that the impression will maximize? First thing we can notice is either we will play second album first, okay, and then first. We have two options, or we can put these albums like this, 1 and 2 or 2 and 1. One thing we can notice is if I play the first album, its maximum value is 10 and its maximum value is 9. Then if I play the first album, then all of the elements of the second album are lesser than 10. Then they will not contribute any impression to Masha. If I play the second album first and then the first album, then some elements, some tracks of the first album can contribute to Masha's impression because its maximum value is 10, and otherwise in this case the second will not contribute anything, but in this case the first will contribute. So one thing we can observe here is we can sort, let us say we are given these albums, then we will sort these albums in increasing order of their maximum value of track, maximum value of coolness of their track. Maximum value of coolness of their track. Okay, so after sorting this, we would like to decide which album we should choose first and which album we should choose like for the later. So one thing we can see is we would like to take some subset of these sets after sorting this. Let us say our modified albums are these. Okay, so we would like to take some subset of these tracks and play them consecutively, let's say some I. Okay, and then put all of these remaining after this. Okay, put all of these after these tracks, such that they will not contribute, but these tracks, these albums will contribute. So we would like to take some subset and place this subset like this, and calculate its impression. And we would like to calculate impression, and for each subset, by taking all of these iterating over all of these subset, we would like to find its impression and take the maximum over all of these subset. Now if we just try brute force, then it is exponential, we cannot do this. But after having such a intuition, we can think of dynamic programming. Okay, so let us try to solve this problem using dynamic programming. Let us say we have made a dp state, dp of I, let's say dp of j, dp of j, dp of j represents the maximum impression for albums such that maximum coolness of tracks is j. Okay, so let us say currently we are on a ith album, and we would like to update our dp state, and let us say its track values are c1, coolness of the track values are c1, c2. Let us say it has m tracks, and we would like to update our dp state for this album. Okay, so first of all we would like to find the maximum coolness we can have using this album. So let us say we have discarded first I-1 tracks of this album. Let's say they are not contributing, and let us say the ith track is contributing to the impression for master. Now what will be the let's say maximum value? We are taking a variable maximum, initially its value will be 0. Now we will be iterating over all of these tracks such that first I-1 tracks are not contributing and ith is contributing. So we will maximize this variable as mx, maximum of mx comma dp of k plus value of I. So let me explain what are these things. Okay, so k is here, my k, I will take the maximum over for all k such that k is less than Ci. Okay, for all of the coolness whose value is less than Ci, I can take the contribution for all of the dp states. Okay, and let's say if the coolness is greater than Ci, then this Cith element, Cith track will not contribute obviously, so K should be obviously less than Ci. And then what is this value Vi? This is, let us say, if I have uh, taken this track, this, let us say this track is contributing, then I will iterate over all of these elements starting from I, and whose values are increasing, let us say, which are contributing. So this value is what is this value representing? Value of I is representing, if I am taking the ith the coolness value of ith, let's say the ith track's coolness value is contributing to my answer, and forward to this, let's say if there are some tracks which are also contributing to the final answer state, then I will take the maximum of these. So this will be, actually this will take much time. I would like to optimize it. How I can optimize it? I can store these DP states in segment tree, so that I will be able to find this maximum value in log n time, and I will store these values. I will pre-calculate these values by using some stack. Okay, by using stack, so that I will be able to find this value in order of one time. So let us see by code how we can accomplish this time complexity. So here I will be using segment tree to store these DP states. Okay, and now here A will be storing the albums. Okay, and at the end of this each track I will be storing its maximum value also, so that I will be able to sort all of these albums in increasing order of their coolness value of track. Then I will iterate over each of these album. Here this vector is representing the track's coolness value for the ith album, and now I am going to, now here dp is representing actually this value. It means that here this value is I am representing it with dp. Okay, so first I would like to calculate the dp. What does it mean is, if I am taking dp of I represents, if I am taking the ith contribution of the ith track, then what will be my contribution for all of the tracks that are greater than I, greater than Ci. Okay, so this I can easily calculate with the help of stack. I can maintain a stack, and dp of I will be size of stack, and it stack is actually containing the decreasing order elements in decreasing order. So after calculating this dp state, I can iterate over all of these tracks and take the maximum, like what is this tree dot query maximum? I am taking from 0 to vector of I minus 1 maximum from these dp states that are stored in my segment tree, plus dp of I. dp of I is actually value of I previously. Here I have seen this is actually dp I am representing there, and this value I can calculate from the segment tree. Okay, so in this way I am able to calculate my result. I am storing the maximum value of all of these tracks in result. So finally I can update my segment tree. Segment tree is storing the dp states. I can update it, like if I am taking the contribution of this track, this album, then it will have maximum value as vector dot back, which I am storing in end position. This is mx. For each track, for each album I am storing its maximum value. So I will update my segment tree corresponding to this maximum value of coolness of this album with result. Okay, and finally I will take the maximum. I will print the maximum value of all of these albums, all of these dp states. So I hope you got the solution. Thank you. I Okay, thank you.